Hello, my name is Adam Martin Becca. I'm a DevOps engineer. Welcome to my free course on Terraform. This is my introductory video. However, even though it's introductory, I will be sharing my screen to provide some hands-on demonstration of theoretical knowledge as well as some commands to get you started in Terraform. Whoa, is that a sword? Yeah, it is. Now pay attention. Terraform allows you to manage, configure, and deploy your infrastructure, platforms, services, and applications that run in your environment. Terraform is open source and declarative. Declarative is the alternative to imperative. Imperative means you're going to define exact steps to get to your end result. Declarative means you want to declare and define your end result, and you don't really care how it's going to get done. You just want it done the way that you've defined what done is. I'm going to get more into those differences later on in this video after I explain a couple more core beginner concepts to get us started. Let's imagine we're building a brand new infrastructure on AWS. We spin up some virtual machines, we add some containers to those virtual machines, and those containers are going to be running some applications as well as databases. In order to establish an infrastructure like this, we need two main initial steps to get something like that started. Our first step is go on AWS to set up a private network space with some EC2 instances. Set up Docker on some of those servers and some other tools that you need. Step 2 is then to deploy and develop the applications onto that infrastructure. Now usually there's two teams. One team each dedicated to one step each. You would have a DevOps team working on step 1 to provision that infrastructure. Then you would have a software development team coming in working on step 2 to develop and deploy all the applications and software for that infrastructure. Terraform is where this comes into step 1. Terraform is an incredible tool for provisioning the infrastructure, to prepare it for application deployment. We can use Terraform to create VPCs, spin up servers and containers, create AWS users and permissions, and spin up Docker containers within the servers. And all of these might need to be done in a correct order too, because sometimes tasks depend on precursor tasks to be finished before those tasks can be complete. So these need to be done step by step in the right order in order to be provisioned properly. Terraform uses the help of providers and resources to get tasks done. Terraform has over 100 providers and over thousands of resources. What's the difference between a provider and a resource? Well, a provider is something like Amazon Web Services, Kubernetes, Google Cloud, or Fastly. Resources are features that those providers are offering. So Amazon will have resources such as EC2 or users, whereas Kubernetes might provide resources such as namespaces, services, and deployments. And the range of providers is anywhere from infrastructure as a service to platform as a service to software as a service provider types. You might have heard of different software similar to Terraform before, such as Ansible and Puppet. What are the differences between Ansible, Puppet, and Terraform? Well, right off the bat, we know that Puppet requires agents. Ansible is agentless. So right away, we already have two differences between Puppet and Ansible. Puppet only works with certain systems that have an agent installed on them, so Puppet can push those updates over to it. Ansible is agentless, making it incredibly useful for Cisco networking gear that doesn't allow third-party software to be installed on their operating systems. Terraform, on the other hand, is mainly used for provisioning and creating the infrastructure. All three of these tools is what's known as infrastructure as code. All three of them are used to provision, manage, create, and update and keep infrastructure managed from a centralized location. The main design purpose for Terraform is to provision a new infrastructure. The main design purpose for Ansible is to configure and manage an infrastructure that's already existing. Although, even though that's the case, Terraform is still amazing at managing and configuring infrastructure that's already there, and Ansible can still be used quite effectively to provision a brand new infrastructure. So they can all kind of be used for the same thing. It's just Terraform is specifically created for provisioning infrastructure, whereas Ansible is created to configure and manage infrastructure, but they can all be used for pretty much anything. So let's go back to our scenario where we finished step one. Step one is provisioning and creating our infrastructure. Step two is deploying all those services and scripts and applications to our infrastructure. So what's step three? Maybe step three is already after the product's been released, or maybe it's still in the development stage, not been released yet. You only have one environment, you got a couple of services, but now you might be getting some users or stakeholders coming in, and the project's looking like it's gonna turn out pretty good. So you start adding new features, new services. For that, you need to start adding more services. So more servers, more containers, more microservices and applications. So you need to start growing, expanding, upgrading, adding new configuration parameters, adding new security features, and updating your servers as new updates start coming out, because new vulnerabilities keep coming out. So you gotta stay on top of your updates, making sure that there aren't any vulnerabilities out there that are super high risk that might be causing your company to be at risk at the internet. And a huge important part of infrastructure is that you have duplicate or multiple versions of the same infrastructure. In IT, a lot of times there is a development infrastructure, then there's a production infrastructure. But sometimes there's a third infrastructure that can come into place, and that's called the staging. So these are called environments. 3 environments. The development environment is kind of the sandbox that you can mess around with. The production environment is where all the users on the internet who don't work at your company, the people who buy your services and surf your website to use your product, that's what those see. This is what they see in the public. Staging is a duplicate of that. So when you're in development and you're messing around, you always want to push your production, push your changes into staging before you push it into production. It's not a good practice to only have development and production. You need a middle one that completely replicates your production environment to make sure that's where you're doing all of your big changes and pushes, so you can test it to make sure that works. And you can even go a step further to have a duplicate staging environment. If your production environment were to go down due to a change that you thought was tested, but turns out doesn't work, then you can always just replicate it back over from that backup production environment. So now let's talk about, how does Terraform do all this? How does it do everything? What's the brain behind it? And how does it connect to Amazon Web Services to create user accounts and permissions and spin up EC2 server instances? And how does it go into Kubernetes and all these other softwares and providers to go and communicate with them to do its thing? Well, Terraform has something called a core. This is the Terraform Core, and the core has 2 input sources. One input is the tf config file, the Terraform configuration file. I'm going to put some examples of what that looks like in a little bit after we explain these concepts. This configuration file contains code and context written by me as the DevOps engineer, telling Terraform what I want my end results to be. Then we have our second input. Our second input is state. State is the memory, database, or list or whatever that shows all of the things that Terraform needs to know to remember exactly how our infrastructure environment looks like. So when these 2 pieces input into the core of Terraform, Terraform then looks at what needs to get done and how is that different than the current configuration. And how it's going to do it, the step-by-steps, is going to be provided by the provider and the resources that it's connected. So for example, if you're running a state deploy on an AWS platform with Terraform, then Terraform is going to reach out to AWS depending on the resources and see what the step-by-step is to execute the plan to get that end result that you put in with the config file. So with that being said, let's take a look at the config file. I'm going to share my screen right now so you can see what's going on.
So here's an example configuration file. This one in particular is a Kubernetes. Let me grab my pen, blue pen. The provider is Kubernetes, and here is the configuration context that we want to plug into it. And this is the resource that we're using by Kubernetes that's going to tell it what steps to take to create the end result. Here's another configuration file. Our provider in this one is AWS. Here are the details and configurations we want to use for it, and this is our resource. So this is a VPC, which is a virtual private cloud. So essentially we're creating this VPC. The configurations that we're going to be using from the provider is the version 2 and US East 1. And the resource configurations is just going to be this CIDR block right here.
Let's go more into declarative versus imperative. So a quick recap of earlier. Imperative means you define the step-by-step that you want it to take to get to the end result. Declarative means you just want an end result and you don't care how it gets done. Sometimes it's not ideal for automation to get something done without the steps not mattering. So you gotta pick and choose where you want to use Terraform. When you're creating an infrastructure, provisioning, and doing most configuration management tasks, a lot of times the steps in between don't matter that much as long as Terraform is reaching out to those providers to get the right instructions. So let's say we want to give Terraform some instructions to remove 2 servers, add a configuration to a firewall, add a new user, and add some permissions to it. So imperatively, if we need 7 servers but we have 9, then imperatively we have to specify to remove 2 servers to get 9, so we have to do the math on that. We need a specific firewall configuration. If it doesn't already have firewall on it, or it doesn't have the firewall configuration parameters to make that configuration possible, then we have to go in and set all of that up ourselves to make that happen. If we want to have a user with certain permissions, then we have to go in and create the user. We have to go and add the permissions to it in AWS. With declarative, we're simplifying everything. We're not telling it that we have 9 servers and we want to remove 2 to get 7. We just say we need 7 servers. We don't care if you're removing or adding. We don't care how many servers there are. We just need 7 servers. Do what you need to do to get that done. And we need this firewall configuration. We don't care if it has a firewall on it already or not. Doesn't matter. We need that configuration. So install whatever you need, put on any other configurations to make that happen. If we want to have a user with certain permissions, then we just tell Terraform what we want, and whether or not that user exists or not, Terraform is just going to create that user if it doesn't exist and make it happen to have our end goal created. So declarative configuration does not care about anything, it just makes it happen. So let's jump into my computer now to explore some of the commands and the more theoretical technical parts of Terraform so that we can get started in our labs and continue on with this course.
Here are a few commands that just kind of do the basic management for Terraform. We've got refresh. Refresh essentially refreshes your client to pull all of the latest information about the current state of the infrastructure. You might do this if you've been sitting on the Terraform program for maybe a couple hours without touching anything, and maybe someone else in your team has already pushed a change with Terraform within the last couple hours. So you want to make sure that your Terraform is always refreshed and up to date before you execute a plan or destroy something. Which brings us to the next command, which is plan. Plan is to create an execution plan, and it's one of the commands that you use to set up your configuration before you apply it. The next one is apply. This one executes the plan that you have put into place to make a deployment, or a change, or an update. The next one is destroy, which destroys resources, it deletes infrastructure pieces. It's extremely destructive, so use it with care.
I hope you found some value. I'd like to thank you for watching.